Now let's have a look at a centralized high-definition CCTV recording and viewing system. So here we have our high-definition cameras, megapixel, and they can be generating MPEG-4 streams, H.264 streams, possibly in some extreme cases motion JPEG, although that will impose a huge loading on the network. And they will be coming through the switch architecture of an organization, and then coming into a centralized video management system comprising of video management server and some kind of network-based video recording. That might well be a scalable NAS solution or something of that ilk. For information being fed to viewing clients, then that'll be streamed out again from either from the cameras directly or from the storage system, and then out over the network, again over the client's network, into the viewing and playback workstations, and these again will be either MPEG-4 or H.264. But note there that if they are H.264 streams, then because of the processor requirement for a single H.264 stream, and that gets multiplied in the case of multiple cameras being decoded, then that imposes a very high decoding workload, and therefore we require very substantial high-powered PCs as our viewing workstations. Also, it's important to note that all of the camera data is being imposed also onto the client's network, and so therefore we're going to need a network of very high capacity in order to be able to take these 2, 3, 4 megabit streams into our recording solution and then back out to our viewing client. So that imposes a large workload, both in terms of high-powered PCs at our viewing clients, and also maximizes the amount of data at any one time on the client's network. So how does that compare with providing high-definition CCTV systems the Netvu connected way? Well, that allows us to provide seamless integration of high-definition CCTV with standard analog CCTV. It allows us to display our high-definition megapixel images directly onto HDMI monitors. So that means that the local user interface creates no network traffic whatsoever other than the camera sources coming into the DVR. Also, it eliminates any security or reliability issues that may be present by the use of a PC as the local viewing interface. It also further strengthens the recording at edge of network architecture, which is a fundamental element of the Netvu connected technology. The unique built-in transcoding architecture allows us to optimize the images being streamed from our DVRs to suit the connectivity to the viewing client, with minimal impact on the client network. We even provide on our high-definition CCTV recording devices dual network interfaces, and typically that allows us to segregate our camera data from our high-definition cameras, our megapixel cameras, and the client data going out to the remote viewing workstations. So this enables us to manage our network traffic far more effectively. And all of these things are far more important to the successful deployment of real-life CCTV systems using high definition than mere fractional data reductions achieved by applying H.264 compression. Remember that all CCTV system vendors currently advocating H.264 are limited to baseline profile, and that in general will create a bandwidth reduction of typically 20 to 30%. So minor data reductions are far less important than being able to deploy real-life high-definition CCTV systems on real networks. Now let's look at a Netvu connected high-definition CCTV system in practice. So notice here to start with that all of the megapixel cameras streams are connected through a dedicated switch and fed into a dedicated port, a separate gigabit port on the high-definition CCTV recorder. So although these cameras are generating high bandwidths, maybe up to 2 megabits per second or more, per camera, then none of that data is impinging itself on the client network. It is all kept totally separate, allowing for much greater network management. Also, we can integrate analog cameras, either static or PTZ, into the high definition CCTV recorder alongside our megapixel images. A local interface here is provided by an HDMI interface, so we can plug in directly our high definition displays and a conventional control keyboard. So again, our local control client impinges no data whatsoever onto the client's corporate network. When we do want to monitor remotely, when we can provide that by a separate network interface now into the client's network, either locally as a local area network viewer or a wide area network viewer, and the transcoding capability inherent within the Netvu connected DVR allows us to actually generate streams to be sent over to remote viewing clients to suit the connectivity between the client and the server. So that is showing the use of our unique transcoding architecture both for live and for playback images. And notice also we could also handle very straightforwardly any mobile viewing client over very low bitrate connections, again using the transcoding. So we can take our megapixel streams, record them at full resolution on our high definition CCTV recorder, and view those cameras either live or playback using the transcoding architecture on a mobile, a wide area or a local area network viewing client, totally seamlessly. Let's see how high definition CCTV can be made scalable, and a very straightforward process here both for a local control room or a remote control room, achieved through a viewing client such as pick-a-point view stations at each control location. And again, our high bandwidth camera streams are kept local to the DVR, meaning that none of that high bandwidth data impinges on the client's network. The only data on the client network is there to satisfy the needs of viewing either remotely or locally. So again, we're managing to minimize the amount of traffic on our client's network.